Shakespeare. I almost make it into Shakespeare mode, but then AppSec and sonnets. Maybe I'll ask GPT to actually create a version of this with sonnets. Let's see what's going to happen.
And on that note, here we go, Francesco, for another masterclass on AppSec, and today he's going to talk about to fix or not to fix. This is the question, as it always comes down to context, making sure we have context, and he's doing some amazing work on this. So over to you.
Thank you very much, Denise, and everyone. Welcome to another masterclass or session. We'll keep it live, we'll keep it interesting. And we've been discussing a lot about application security, vulnerability management, cloud security, on whether to fix something or not to fix. We got in the recent news a lot of examples where specific threat feeds were more interesting versus others. So there is a lot of question around what do I use as a North Star to actually fix? And I wish I had a better answer. It depends, but we will, as a silver lining, we will explore all the feeds and cases and scenario where this is, which feed to use where. Just a little bit of background. I'm Francesco Cipollone. I'm the CEO and founder of Phoenix Security. We do this day in and day out and analyze and spend a lot of time looking at different data analytics feed and how to make life easier, close bracket. And this is what we called Shift Smart. So focusing on what's really matters in the context and scenario where it matters, because certain things matters most, certain things matters less in a particular scenario versus the other. I'll have to apologize or not apologize. Maybe this slide deck and this presentation is a little bit lighter on memes. Usually I do an insane amount of memes, but there is a reason for it. Security, application security is really heavy sometimes. It's a battle. We are in the trenches fighting to protect our organization day in and day out. And if we don't have a jokes here and there, if we don't have a little bit of banter for my British folks, it becomes heavy, it becomes dramatic. And if we approach this problem with a little bit of a smile, with a little bit of banter, then it's a little bit lighter. And that's my mission on this presentation, to make it interesting, but also lighter. I've been doing vulnerability management at scale in several organizations, from finance to telco to international organization, and I've seen it, I've done it all. And I think my mission to actually continue doing this and prioritizing and focusing on what really matters was preventing burnout, because doing things manually, focusing on everything, focusing on the latest superstar vulnerability, is not really helping anybody and is burning us all. So can we scale and make it more enjoyable and available to everybody? The answer is yes. So what we're going to talk today, we're going to talk about security development, the human cost of triage, the SDLC approach, and what to fix immediately, what not to fix. And then we're going to explore a lot of terms that have been going around, and I think they need a little bit of contextualization. Reachability, context, and exploitability, they are not interchangeable, and they need a little bit more knowledge, and also how and where we use this, in which area, and how complex it is to measure and use all of this, because vulnerability management is all about what information and feed I use, where, and how complex it is to use. If I spend more time actually measuring and trying to identify the best approach to prioritizing, and I don't have time to actually go and fix it, then it's pointless. So which tool do you use where, and which one deliver the best ROI or return on investment to us? And that is where we focus really a lot today. And then, of course, all of this get captured in the risk. As I say, the risk is the great unifier from the great divide that is vulnerability. And this deliver really, we wrap up everything into risk. So the first time you start a security scanner of any sort across any organization, or the first time you enter an organization that hasn't done vulnerability management, this is a scenario you are faced with. A lot of red, a lot of critical, a lot of burning. And the more important question is, who should fix what and when? And if you work in a development environment, well, you have a lot of things to do, and then you have the security engineer, the development engineers, the cloud engineers, security engineers, and so on and so forth that open tickets for you. And very quickly, you find yourself in a sea of red or backlog. What we don't usually ask and answer is, who is in charge of actually doing and continue working on the stuff that keeps the business running, right? Because having a lot of tickets in a backlog doesn't mean security. And doing triage manually is extremely complicated on both sides of the dev divide. So in your dev team or in your security team is the same level of challenge of actually triaging and identifying what to fix next. And doing this all manually is the road of burnout, because traditionally an organization has at least 2 or 3 of these tools. You have web testing, either open source or non-open source. You might have security static analysis. You might have DAST or dynamic application security testing, a cloud security product, an infrastructure product. Looking at all of this information is challenging. And on top of that, you have pen testing. And on top of that, you actually have threat feed and the latest vulnerability and the latest panic that happens from management, that happens from everyone. This is not a right and a good way to go, and it's not scalable, because our attention gets pulled in every direction, and we don't unfortunately have infinite mental resource time and infinite time. And this is not news. Hopefully I'm talking and I'm preaching to the choir, because this is what we face every day. And if you're a small organization that has less than 1,000 employees, 100 devs, you can probably still kind of handle all this manually with different level of expertise, but the surface is not insane. You can still dedicate enough amount of time to each team. And the more you know each team, the more you know each application, the faster you become in analyzing a vulnerability. And 48 minutes per team per week is actually not that bad numbers. You have roughly 2 or 3 security teams, or 1 to 50 security to dev. Probably not an insane amount. It's still a lot of work, but it's not an insane amount to manage. Probably you will face it when it becomes at scale and challenging, when you have the superstar vulnerability that comes, like the Log4Shell or Spring4Shell or the OpenSSL. And we start seeing those more and more, but it's still kind of manageable. Where this becomes really challenging is probably when you get to a mid-sized to enterprise level or to larger organization, where you have roughly 3,000 and more employees, you have 1,000 devs and much less security team. So if you see the security team do not scale at the same time with the development team, and that's one of the reasons why we keep on saying security is everybody's responsibility, because we don't have enough resources to actually put our hands onto the problem. And if you see here, the amount of time it takes us to get through the vulnerability for a specific team is much, much less. So we have less time to triage, less time to identify the vulnerabilities, and we really need to focus on the vulnerability that really matters. So this is where risk management and vulnerability management at scale really deliver the best benefit, because we get time to actually focus on what really matters. And we should remember that the job of security is not to fix everything. It's not to fix all the vulnerability. We should help the business fix the vulnerability that are in line with the risk expectation. So we should just operate to the level of risk that the organization is comfortable with. And sometimes in security, we get kind of wrapped up, especially if we're pen testing, especially if we identify a problem, but we identify a problem atomically, outside the context of where that problem happens and outside the likelihood of where that problem happens. Can somebody exploit a specific vulnerability? Yes, probably, with some level of effort and some level of expertise. But if that vulnerability is buried down the stack, and if very little chance that that vulnerability is going to get access, or if that vulnerability is web-facing and everybody's looking at that vulnerability, those are very 2 different critical. And it might be the same level of vulnerability, might be the same Log4j, the same critical vulnerability, but in 2 different level and context, and with two different levels of likelihood. And expressing that to the business, we enable the business to actually make a decision: do we fix, do we don't fix? Because ultimately, the only people that will authorize our dev team to actually go and work and focus on fixing vulnerability through the backlog and prioritizing those things through the backlog is going to be the business. So how do we involve the business into making the right decision? Well, we tend to focus on shift left and shift right. That is, moving things early in the development cycle or focusing on production. And we've been focusing as an industry a lot in that. We hope that DevSecOps, and I'm sorry for using all the terms, you can use the security bingo and trying to identify how many keywords do I hit. But we've been focusing as an industry on these two terms and going left to right and right to left and left to right. And security has been kind of in the middle, trying to help both options. But the third option and the third kind of key players that we forgot was the business. And it's the business that fundamentally set the risk level where we should operate. And that is going to be the only one who is responsible on actually driving the business and fixing vulnerabilities. The only one who has the right to say, I'm going to spend X amount of development time and cycle on that problem versus the other problem. The challenge that we have is that we tend to speak vulnerability to executive and to the business. We say 10,000 critical, millions of vulnerabilities. And if you're in any situation like me in the past, you get very awkward look, very awkward feeling from management team where they say, what do you want me to do with this? Fix them all, how bad they are. We were surviving with this yesterday. It's not something that can make an informed decision because anybody from a business perspective think in risk, and we need to contextualize vulnerability for them. And on the opposite side, if we go to an engineering perspective.
Can I just add a quick comment there?
Yeah.
I think you just touched on something which I found that more and more I think is important, is that especially when you talk to executives, I think it's very important that we have a coherent story, for example, of why it hasn't been exploited. And I think because, you know, it's a bit like, imagine you walk into a building and say, hey, this hole has massive gaps. And the people in the building going, yeah, but the building's been here for 100 years and we haven't had a breach. No, it doesn't mean that you cannot say luck, right? I think luck is a valid, you know, a valid reason, right? Or you can say we haven't had attackers who are sophisticated enough, or we happen to have somebody who done some heroic actions. But I think it's, especially at an executive, I think is, as you put context, they're gonna drive you to have a rational reason for why now, why not in 6 months from now, why not in 12 months from now, or what's changing in order for this to now be a problem, which is the kind of questions that the context will drive. And I think that makes a lot of difference as you talk to executives.
And usually, yeah, and you give them kind of the North Star that is, as you rightfully say, Dean, is the probability. You give a sense of probability. It's not an atomic value. This is not bad atomically. It might be, Log4j is a very good example where a vulnerability that was discovered ages ago that all of a sudden got attacked at scale now becomes a really important problem. Another good example is movie transfer. We had this vulnerability exploited 8 months on a specific attack. It wasn't important before, it's super important now. Now, depending on, I wrote recently an article on that depending on which threat bit you look at, the probability and the exploit at scale is very low right now on the movie transfer. But the threat actors that are actually exploiting that are very targeted. So that in itself requires that level of context and a story around that vulnerability. Yes, that vulnerability exploitation is very low, but if somebody attacked us with that vulnerability, then we're going to face the same level of challenge that we had in Boots, we had with British Airways, and so on and so forth. So the magnitude, that is the second aspect of risk, is really, really important. And the narrative that you build around the vulnerability is really important for the level up. But then we need a connection from level up to level down, because if we tell that story to engineering team, engineers don't bloody cares about all this story. They just want to know, what do I need to fix in the next sprint? And if we tell that narrative, that's great. But ultimately, we need to give them a number of story points that they need to allocate in a sprint. And as a security team, we sometimes forget that that's our job, to give them a visibility on what to do next and the week after and how important it is, and then let the business manage at Scrum with existing process, not reinventing the wheel on new process, but giving them a consistent stream of things to fix that are contextualized and important for the business. Not reinventing the wheel, very boring, but that's what gets things done. Not talking about risk, but talking about what needs to be solved next in line with risk, expectation, and everything else.
Yeah. You know, one of the words I found myself using a lot when I talk, to my more technical teams, I say, your responsibility if I'm on a security team is to produce highly defensible analysis that when somebody with knowledge about that really looks at it, they go, I get it, I understand. It's almost like you're also forcing us on a security team to actually produce really good materials for. And
it sometimes a hit and miss, but giving consistent list of things and giving an ability to actually challenge those things and adding context and having that discussion give much better result than just flooding a backlog with 2,000 tickets, because that will never get done. Absolutely. Like even 10 on a sprint, when you have to produce other 15 features, it's an imbalanced approach. Like 1, 2, maybe per sprint. That's the level of bug fixing that you can foresee and forecast. And sometimes as a security team, we miss that. And in maybe we have 1, 2, 3 shot idea when we have the superstar vulnerability like Log4j that we all focus on, where we can all hands on deck focus on fixing a specific problem, but we don't have a lot of chances like that, and they are expensive in terms of cycles. So even in those superstar vulnerability, focusing on the one that are more likely to be exploited and forgetting about the other one that can be fixed, maybe even not fixed in a normal cycle of fix versus building, and keeping those measurements is really important. And I'm going to stop at specific point with questions so that we'll have time. Otherwise, I get into rabbit hole with these things. But I want to say that, on the other hand, we tend to oversimplify why security is complex. And application security, I've talked it extensively, is complex, is variegated. I don't want to oversimplify with this explanation and with this presentation that it's just risk or it's just a list of things. Context and vulnerability and risk are extremely nuanced. And I'm going to focus on application security specifically for this case, and focusing on the central part of application security, or an SDLC at a very high level. That is the process of designing, building, and test, and operating. And I'm going to even narrow it down to build and test and operate, where a mature SDLC nowadays look like that, because we have a lot of moving components. We have code, we have testing in build, testing in operation, we have things that are being deployed, and there are time and place when to fix and when to make decisions. And sometimes making a decisions in an IDE in a rapid mode is actually much more valuable than looking at all the context in the world. So there are time and place when to look at contextualization and when to look at fix it now because it is visible and you're going to spend the minimum amount of cycle. Of course, there needs to be a balance, because we can't fix all the vulnerabilities as soon as they appear, because maybe it's a major upgrade of a framework. Maybe there is a better way to fix a vulnerability. And those are the things that I call fast triage. When you decide at IDE point, so when you are developing something, whether to fix a vulnerability or not. But then there is the rest and the remaining part of the vulnerability backlog, that is everything else. And as soon as you turn on the vulnerability, a vulnerability management solution, you will find a sea of vulnerability. So those vulnerabilities need to be prioritized and then need to be decided. And as well, you might find something that operates at development cycle, but a lot of the vulnerability like Log4j, Spring Post Shell, movie transfer, and things like that happens at operational level. So we need to keep a balance of prioritized backlog on the right and things that we fix on the left. And having a single approach on either one of these will not work, because they're two different speed, methodology, and approaches. And as I said, as soon as you join, the point of vulnerability management is identifying who should fix what and what's most urgent and giving them in the backlog in a prioritized way, because flooding a backlog with all the vulnerability in the work will reach to burnout, will result in development team not listening to security at all. And it's not the way to go. Flooding a development team with this is the equivalent of asking the security team to develop features for them, because security is everybody's responsibility, but what is the responsibility of somebody else in terms of developing, in terms of delivering feature to the business? So we need to empower the business to make the right decision with the right tools at the right time. And we are in this situation because manual triage doesn't scale. As a security team, we tend to flood and delegate, but it's almost like finding a needle in a haystack. But the haystack is on fire, everything is screaming, and this is what normally happens as soon as you turn a vulnerability scanner at any point. And the rationale for this is that we are completely unbalanced between the number of security researchers and the number of development, so there will be always an imbalance in this. And we'll need to find a way to actually scale vulnerability management. But the good news is that not everything is exploitable in that particular point in time. 10% of the vulnerability, accordingly to the latest research, is actually exploitable. 5% of those are actually reachable, and 1% vulnerability are the ones that are target now that you should really focus. And I'll use this term interchangeably here, but actually I'll explore them much more and expand them much more. But just for few statistics, CVSS is actually reaching the 20,000 or 200,000 vulnerability right now, of which just very little percent are actually exploitable. And the speed of fixing is actually increasing over time. And if we just use SLA, first of all, we're late because attackers are actually attacking things faster than we can actually exploit, because we focus on all the vulnerability. And SLA, or service level agreement, or how long should we fix and how quickly should we fix things, are actually two simple metrics to use and deliver no results. Like there's been a few Gartner studies that have identified that using an SLA-based approach doesn't work 100% of the time. Like it never works. And the reason why it doesn't work is that the triage is nuanced, and you can use different things in an automated versus unautomated way. So I want to spend a little bit of time on this because I've been doing a lot of research on this, and I think that there've been a lot of assumption that triage is straightforward. So I want to break this, and I want to break the triage in easy as automatable. We have data source, we have things that we can identify, or very hard, where things are really hard to automate. Hence, we rather spend time doing things manually. And it's a balance. Right now, we overly balance on the right. I want us to be in a balance between left and right. So let's say bulk. So bulk is the first cut of vulnerability that we get from different scanner at different points. And I want to say, this is stuff that we can automate. There are different levels of nuances of what you can automate, taking different data feeds. Exploitability, active bounties, vector, reachability in terms of code. We go from very easy, EPSS is available everywhere. An attacked vector is available, is CVSS-based. If it's CVSS, CWSS-based, is there an active bounty? Is there an active exploit in the wild? You get threat feed around a specific vulnerability. All of this information are machine readable and can be automated and can be used in an automated and scalable way to remove 80% of the vulnerabilities. Now, the deeper you go in the code with the concept of reachability, and we're going to touch on the concept of reachability in a moment, the harder it becomes to actually track this and do things at scale. It's not impossible, but again, it's a balance between how much effort you put in the automation part versus how much you get out of it. If it takes you hours and hours and millions to actually develop a technology, or to actually go and scan each single line of code and find which single line was fixable versus a decision of 10 minutes. Do we fix it? Do we don't fix it because it's reachable with a team? Decide where you spend your time, your energy, and effort. The second complexity or the second screening will be locality. Locality gives you the concept of where things are in your environment and how likely are they to get exploited. Again, it's a nuanced approach. The likelihood derives by the intention of an attacker, but it's a good indicator of the more external you are, the more externally facing you are, the more likely things are to be exploited. And you can have those information in CMDB, you can have this information in any data set. The lower you go in the stack, the lower you go in this particular stack, exploitability, location, reachability, attack paths, you get more nuanced in the location and the likelihood of exploitation of a specific vulnerability, and it takes you more effort and time. So unless the vulnerability is really sophisticated, it's probably not worth to spend so much money, energy, and effort on actually an attack vector or an attack path analysis that delivers you maybe good results, but you probably have spent an enormous amount of time and effort that could have been saved. And second, business criticality. And the more we go right, the less automatable information, the less information you have to use in a machine readable way. Hence, it's harder to get automation. And hence why I say the left part of this triage and staging of triage is automatable, because you have widely available information at scale, or there are provided that offer you. But the more right you go, the more this information depends on your organization, on your particular context, and not every time is actually automatable. This doesn't take you, this doesn't mean that shouldn't be an incentive for you to actually go and automate a lot of this stuff, because there is a lot of benefit from it, and it's probably not that complicated. But for example, in a business criticality, a number from 1 to 10 on an application is easy to say. A full fair analysis is probably more complicated to implement and to even understand. And the last bit that is where really the manual effort comes into place is the business decision, is the internal rationale is, do we fix this particular bunch of vulnerability, or do we upgrade this library, this framework? Those decisions are really hard to automate, and in my opinion, shouldn't be automated, because it's all contextual on the particular business initiative that you're having. Do you fix all the operating system, or do you upgrade to a new operating system? Those could be just business reason and decision that are supported by a lot of this information, but are the decisions where actually human are really, really adding value versus automation and machine, because most of the time this automation leads you to a straight path.
Just a quick one. I think
yes.
on your left, a good source is also incidents and threat intelligence.
Yeah.
I think internal incidents, and especially like, for example, like I talked about before, like one of the things I tend to do is we tend to run sometimes P1s, P3s and P4s and P2s, that's P1s. And one of the things we get is really good data on either what happened or what was just 1 degree separation away from happening. And that again allows you to prioritize a lot of these, because in a way that's, in fact, I would even argue that sometimes we fix a lot of things during those incidents, but it's really, really good data, because it's almost like this just happened. It's not like theoretical. It's like when, you know, the last thing of, is it reachable? Well, it just did. You know, it's like, well,
if you get hit by a vulnerability, it's like there was a very good Second World War where they analyzed and they reinforced the planes where they got hit. So do you reinforce the plane that got hit, or do you reinforce where you didn't see the plane coming back? So it's a little bit of a nuanced approach.
I get it, but it depends how you approach it. Like, so for example, like I would call a bigger problem, for example, lack of detectability. So, for example, if even, for example, when a bug bounty tells us something's wrong, I view the fact that we didn't detect it, the fact that we didn't, you know, have more visibility, etc. That's the kind of stuff that, again, that I want to make sure we understand, because actually also detectability is also quite important here, because you know, if it's a vulnerability that you can be quite confident that it can be detected, or at least you get some warning signs before it kind of hits critical mass. That's way more dangerous than the kind of vulnerability that, although is a bit more esoteric, if that gets hit, then it's a massive problem.
Well, those are things that goes in the triage, goes in the human aspect versus the automation. So, and it's different on any organization where you have the richness of the data.
Yep.
But in general, doing this manually, all of it manually, it's probably not good. And fixing everything as soon as it comes out, it's probably not best. So thou shalt prioritize or die trying. That is my rules and that is my law. But I want to say that I've seen a lot of discussion around reachability, exploitability, and context, and all of these elements and all of these terms are actually different from each other and are very, very different from each other, and have a different level and degrees of complexity in actually extracting and analyzing. And risk can express a lot of this. That's why I love risk, because risk can express a lot of these elements with a probabilistic factor that the business understands. Well, if we express all of these atomically, probably we create a very complicated narrative. But just to demystify a lot of this term, I wanna get to this point where we have a specific library, for example, log4j, in a specific file, and then that particular library is called in a function. That is really reachability. That is where a specific library gets reachable, and that is, if I call it, then that particular piece of code get called, and that particular vulnerability pops up. Detecting something like this requires a lot of effort. We've seen some security scanners that are doing something like this and prioritizing vulnerability with reachability. It removes the false positive, but again, it's a balance between how much cycle and money you need to spend to actually get to that point of deciding, yes, this vulnerability has actually been called by a function that's being called. And a lot of those in-memory scanner actually can help a little bit detecting this, because really see the attack part or the call part of a specific function. But getting to that level is very complicated and require a very granular approach across all your code. So this is, for me, code reachability and reachability of a vulnerability is very, very hard in the stack of automation. It depends on your scanner, but in general, from a vulnerability management perspective, I will classify these as hard. Network reachability gives you a little bit more context where you can prioritize maybe a log4j that is externally facing versus a log4j that is internally facing. I would say reachability and context give you 50-50 of complexity, depending on how good you have your asset inventory and how good you can create your asset inventory. So it's really depends. Exploitability is probably the easiest factors that you can use at scale. There is plenty of information out there. There is VulnDB, there is EPSS. There are plenty of source for you to understand how likely is specific things to be exploitable, and use them at scale. I would say use them with a pinch of salt, because sometimes some of these information are appropriate, especially for application security. Sometimes they are not. We've done a recent study where we screened CISA-KEV. That is one good example of exploitability factor, because everything that goes in CISA-KEV is well documented to be fixable and to be exploitable. So those are the well-known things that are exploited at scale. Hit and miss. And then we cross-reference that with the likelihood of exploitation at scale, or the prediction of exploitation at scale in the next 30 days that is given by EPSS. A number of vulnerabilities were completely missed, others were exacerbated. So use each threat feed in comparison with the other. So usually at least 2 threat feeds, not just one anatomically. And the other element I wanted to say is CISA-KEV is very good from a traditional vulnerability management and infrastructure approach and patch management, versus application security is probably not the best resource, because only 3% of whatever is in the catalog is related to a library or to a piece of code, and there is much more out there that is actually highly exploitable. So it's a very stressed list of things that are exploitable in the patching and infrastructure work. But to wrap all of this up and and to conclude, fundamentally, this discussion is I love risk because risk is the great unifier. So you can use a lot of this information into a risk formula. You can capture the likelihood and the exploitability of something to get exploited, the severity of something to get exploited, and the criticality, so how much it impacts you, into a risk formula that everybody can understand and agree on. And it's a journey. Risk is a journey, it's an evolution where you go from pure severity-based and CVSS, CWSS to SLA-based to risk. So don't adopt it straightforward out of this presentation. I mean, if you want, I'd be very happy about it, that you go into your organization and we say, scrap everything, we should do risk. Yes, we should do risk, but evolve into it. And a number of regulators, unfortunately, still operate with CVSS and CVSS information. But in the silver lining, you can probably add a lot of justification if you express your risk posture and you say, I control my risk posture, hence a lot of these CVSS that in your opinion need to be fixed are actually non-fixable because I can't reach and they can't be exploited at scale or in the world. Usually that conversation goes much better with an auditor. It depends. For me, security is not compliance and the other way around, and hate me or love me for that. It's my opinion. We need to evolve regulation at scale because we still rely on a lot of stuff that is antiquated. But a lot of these factors that I've discussed today can be used in a formula that doesn't need to be complicated. Fundamentally, risk in a modern risk could be your CVSS, your CWSS, your severity. You can express the probability of exploitation in a machine way, in an automated way, with exploitability, with threat intelligence. If there is a fix available, where is the particular asset located? A lot of this information can be extracted and scaled automatically. And then you can express the impact of your business application and how much a particular vulnerability might impact you and how many users and so on. So that can all be expressed in a numerical form. Now, you can go as crazy as you want, and I'm going to slap you with some of the element and consideration of like how to prioritize vulnerability and where to prioritize vulnerability. So you can go as crazy as you want with the risk formula, but in a nutshell, it's simple and help you much more discussing product rather than individual vulnerability, because business people discuss about product, don't discuss about individual vulnerability. And if you look at the information between left and right, if you don't discuss about product, you see just the sea of flat vulnerability. You see a number of critical and you focus on the number of critical. They are uncontextualized, they're not focused on a product perspective. But if you add the context, then you can see a lower priority or a lower impactful business application versus a high impactful business application, and you focus on the right versus on the left. Gut feeling, as soon as you see a lot of red, you will focus on the critical vulnerability on the very long list of vulnerability. Chances are the one that have probably one or two major critical vulnerability that is externally facing, it is highly attacked at scale, is more likely to get attacked. And that discussion helps with the business. So shifting smart is all what I say in trying to get the business into this kind of conversation, contextualizing, adding the level of risk and enabling them to set really the risk expectation or where they want to be, and translating that concept into where the engineer need to focus. Because if you unify the three angles of business, dev and ops and security, then you really reach the nirvana of what I'm talking about. That is fundamentally business driving risk, security being consulted on risk, and developer having a really finite list of things that they need to focus on. And this approach has been proven to actually reduce the noise, reduce the alert fatigues, increase the collaboration, and reduce the burnout from an application security to vulnerability management. And, I'm not saying like tomorrow go out and scrap your SLA because, okay, SLA have worked, but they've been around for a while. They're not probably the best tools, or If you contextualize the SLA, if you use specific SLAs around risk, probably it's much better. And you can use nuance of SLA, and we've wrote probably tons of articles and a couple of books around this, on how can you evolve from pure CVSS severity-based SLA to multi-SLA based on product, to risk-based SLA, and really to security OKR. That is where you should aim to evolve your measurement, because those express much better a balance that the team can then manage internally. How many things you fix versus how many things you build. That could be an OKR, one single security OKR you can put to your team, to your development team, and then let them manage how many vulnerabilities they fix. You, as a security team, should provide always the more likely vulnerability to be exploited, and get the business on that journey. And if I want to leave you with something, is acting on risk and not fixing vulnerability, focusing on really what really matters. And this is my mission to the world. So conclusion, today we talked, we fixed security, probably not, but at least I hope I've given you some food for thought, some thinking process on what to fix next. Fixing every vulnerability shouldn't be done, and it's not feasible, and it's going to only lead to burnout. Reachability, context, and exploitability can be used with different degrees and expense in terms of engineering power, in terms of mental power. And talking risk and talking probability of exploitation to the business is what delivers. I want to give some thanks to the APSS working group that's been absolutely fantastic to seek to produce fundamentally EPSS. If you haven't used EPSS or look at it, please consider looking at that. And then in the whole concept of reachability, there's been a fantastic presentation by Adam Berman, where a vulnerability is not a vulnerability, and also Timo from DSOM that has been fantastic in the whole process of vulnerability management, of which we have a framework available to use a lot of these things. A small takeaway, we are a security company that focus absolutely on this. So if you want to do this at scale and automate a lot of these vulnerability decisions, we're here for that. Stop the pitch. But we love OWASP, and we have a version available for OWASP. So scan the QR code, get your OWASP edition. We want everybody to be able to not burn out and do vulnerability management at scale. And also, if you want to know more, we have plenty of white paper around this that explain and explore on this, and a master book on SLA and why we consider SLA of that, and how you can evolve your organization to go from pure vulnerability management to SLA to security OKR. And also, we discuss a lot about this on the podcast. We discuss cloud security and application security. So I would invite everybody to visit the CSCP. It's also available on our website. And I'm going to open the floor to questions, because I've been talking a lot. Thank you, everyone.
Cool. No, great session as always, man. Yeah, if there's anything, guys, please put it in the chat. You should all be able to. I don't see anything in there, but give it a couple of minutes. And
I can't see the chat, so
yeah, no, I'll keep an eye on it. But it's you know, I think it's that sign of evolution, right? Where, you know, I know we start talking about the chat GPT in the beginning and the AI stuff. I feel that the biggest challenge I always had, you know, with this is a lot of it is like, it makes complete sense. The question is how to scale it in a business that has, you know, that on steroids. And not just that, you know, when you talk about context and talking to the business is not one entity. If you think about it, it's multiple entities with multiple levels of stakeholders, multiple levels of seniority, multiple levels of priorities. And I think now we're getting to the point, not yet, but I think we're getting close to be able to mass customize some of the content we have, so we can really put into context, so we can get to that 10 or 20, you know, things that really matter for a particular stakeholder. And I think we, you know, with the new wave of analyzing a large set of data, and of course, you know, there's a whole thing of cleaning it up, making sure it's correct, make sure it's well, you know, processed. But I feel that we're able to provide to do this at a much highly scalable way. once
I mean, there is LLM, there are language models, so some of these we might find correlation in pattern, but a lot of this stuff is just collecting the data that we have already and really basic stuff. It's not like rocket science, it's just getting everything. And as you rightfully say, Dennis, is doing this at scale, collecting all the vulnerability in one central location, grouping them by product. That is not rocket science. You can have some ML like we're doing, like trying to patternize and see who is maintaining the same repo, and maybe they are all part of the same product, or who is doing the same issue over time. You will start seeing trending and other stuff, even if you do just basic aggregation and basic analysis. Yeah. And then you evolve in these triage. So at the beginning, you will do a lot of triage manually, and then you start automating some piece of it. So yes, AI is very exciting, but it's very likely that it's very easy to get to throw garbage in and to get garbage out. And I'm guilty as charged. Like, I've done this because I get super excited about the new technology, and I said, I'll need to use it at scale. And then I get like good result, bad results. So experiment, yes, absolutely. We have a fantastic tool that is available out there to experiment. Mixed feeling about result, like we've been discussing with Sharif, and he's done some interesting experiment. If you haven't seen this, there's been a fantastic presentation he has done on ChatGPT.
Yeah.
And we're fixing stuff actually, or using ChatGPT for code analysis. I've used it at scale as well myself. And sometimes it gives you the right pointer. Sometimes if you ask them to auto fix or auto patch, remove specific piece of code. So makes the code secure because it doesn't run.
doesn't run the thing, right? Yeah.
But it wasn't taught to be dead. It just happened to be dead because it has a lot of language and a lot of good and bad examples. So maybe if we train something on good and bad example, maybe we'll have some more precise LLM. But as everything, we still have to fix the basic, and we still have to fix the basic stuff, because business context, the way to talk to the business, that's still on us internally.
But that's where I have to say I've already had some good success on prompting, because you can start to prompt the audience that you're going to have.
Mm-hmm.
I mean, you can say, I'm speaking to this person, which runs this, and this is the context, this is the objectives, this is the issues, right? And I think that...
So you're doing prompt engineering on people.
Well, it's context, right? It's basic, it's providing context. And I think, you know, like if you look at the latest stuff on Palm 2 and Vertex, and I think being able to start to teach the models with the data that we have and then fine tune it, you know, it's kind of, you know, this is where the Worldly Maps is interesting, right? Because the LLM pushed all the stuff to the right, and now you're going to start to see these security LLMs coming to market, and they will be very, very laser sharp focused on certain things. The same way that you have a medicine, you know, focus one, you now start to have security, imagine having a risk one, having, you know, imagine feeding, you know, the ISO, the GDPR standards, your internal policies, you know, all the kind of, you know, the OASP, yes, you know, all that stuff, and then starting to
there is already somebody that has developed that.
Yeah, it's super powerful.
Called GRE.
Yeah, it's crazy powerful. So, all right, man. Look, I don't think we got questions here. So thanks again for doing another these great sessions, and I'll see you on the next one.
See you guys. Thank you very much. Stay safe.